Good afternoon. Welcome to EduSet Network. Friend, as you know, we are having discussion on use of software in data analysis. Yesterday we discussed briefly about various software and also talked about the use of Excel sheet. And we'll move further and we'll talk about how using Excel sheet you can do a modeling and other data analysis. And we'll also talk about the application of data mining. And for discussion on this very topic, we have in the studio Dr. O.P. Valli. He is a professor of IT in Indian Institute of Foreign Trade, or premier institute of the country, and he has keen interest of these things. So I hope his knowledge and experience will help us to understand this topic in a new way and give a new insight into it. So on your behalf, I welcome Dr. Valli for EduSet lecture. Welcome, sir.
Yeah, thank you. We had this series starting yesterday. We discussed basics of data analysis and the importance of doing it through a very planned and systematic way, and how we can leverage the power of the software and the software applications to make more meaning out of the data that we have. So today we are going to now take you through some examples and cases and to show how we can actually use this basic software application, which is almost available everywhere with most of the users, is Excel from the Microsoft suite of products. So if you look at the screen now, I can just show you, we have just taken some basic items of sales, quantity, price, variable cost and profit. And if we got to calculate profit, so we can simply write sales quantity multiplied by price per unit and minus variable cost, and if we just press enter, we get this $3,000. Now this is profit. This is one way of doing it, and we are actually following something that I referred yesterday also, that we are referencing. Profit is being referenced rather than put directly into the cell. So if we look at the formula, it looks like this, and a better way of presenting
some problem, you can just stick to the left.
Okay, let me just make it slightly this side, and oh, sorry, just a minute. Okay, is it now? Can you just put the screen? Yeah. Can we have it now? So rather than having the profit as an equation as the way we have put it, I will just take it slightly this side, and now I think we are right. Yeah. Now we can also segregate the profit into two things, is the revenue and the cost. So we can just write it like this, revenue, and we can write cost like this, and then calculate profit. So like that. So we can write the formula for revenue by multiplying sales quantity into the price, and in the cost we can again write sales quantity into the variable cost, and then we can subtract the two by subtracting cost from the revenue. Now what is the difference between the two approaches? In the first case we calculated the profits and these were right figures. In the second case also we calculate the same and the figures are exactly tallying, but the difference is that we have actually disaggregated the figures. We have done much more systematic effort to arrive at the profit. The advantage is that if we are doing data analysis, it is always advisable to break the entire sequence of associations in the data, in the model, so that if we want to do any kind of sensitivity analysis, we can actually see what are the effects on different we can actually vary and sensitize the profit with respect to each and every variable that is modeled in the spreadsheet. Now, the question could be that what will happen to the profit if our price was not 10 rupees but could be in a range of, let us say, 6 to 12 or 5 to 20, whatever. So, there could be different price points which we would be interested to know, and its effect on the profit. So, there is a very interesting tool in the Excel which is called data table, which is under the head data, and if you go to the data analysis over here, you have a feature here which is called data table. So, if we open this data table, we keep it for the moment over here. Now, what we do is, we will just first put the data. We will analyze this profit with respect to various price points. So, let us put these price points over here. So, 5, 6, and we will just let us say up to 12. Now, we want to sensitize the effect of the different price points on the profit, which is 3000. But please remember that this 3000 is actually a reference cell. Sorry, we can just this is a referred cell. So, we are referring B6 over here, and then we are doing the sensitivity analysis. We cannot simply copy and paste it, it will not really work. So, that is important. Okay. So, we go here. Now, what we do, we select this entire area up to this point and then go to what if analysis, take data table. Now, please remember, this time this is basically the column which is to be used to input the data. So, in the column input cell, because we are sensitizing profit on the price, we will take price as the column input and say OK. The moment we do OK, you get all the corresponding profit figures vis-a-vis different price points. So, in a matter of second, you could really do a much faster exercise that otherwise you would have to really write a formula for each and every say sensitivity test. So, this is what we call as the one-way table analysis. We are actually able to sensitize the output based on the one variable. Now, what could be a case if we want to really sensitize the output based on the two variables? So, in that case, what we do is, rather than referring cell on the top on one side, we will take it to the corner and try to analyze this corner cell, which is profit, with respect to the profit price as well as cost. So, vertically I have put the price, let us put cost points on horizontal line. So, what we will do, let us take 4, 4.5 and so on. This is just hypothetical, and we let us take up to 9. So, these are the cost points that we have put horizontally, and these are the price points which we have put vertically. Now, if we select this entire area like this and then go to the data table again, and in the column input this time again we click the price over here. In the row input, because we have taken cost across, so we will click the variable cost over here and say OK. Now, the moment we say OK, all the corresponding profit figures are appearing over here. So, cool and fast. So, if you see now, to cross check whether we have really done it right or not, if you see for a 7 rupees variable cost and with 10 rupees selling price, the profit figures were 3000. So, are the other figures, if you want to really cross check, you can do that. But the question is, in the real world, we are actually not confronting one variable, we are confronting a lot of variables. So, what is the other tool that we can use to analyze the data? So, there we have another tool which is called Scenario Manager. So, if we look at this particular tool, it will open like this. So, only what we have to do is we have to visualize how many scenarios we want and what could be the variable values which we want to use as the scenario. So, let us take the case here. We have, let us say, two variables which are say price and variable cost. Let us increase one more variable over here and take variable cost 1, variable cost 2, and then see how it really works. So, in the first one, let us say this is variable cost 1, this is variable cost 2, and let us then let us put it at 5, let us put this one as 3, and here we are, and only the cost we have to recalculate. That means rather than B3, now we have B3 plus B4 as the variable cost figures. So it goes like this. Now this is the new profit that we have been able to calculate based on now 2 variable costs. So what we are trying to do here, now we have 4 variables here in total. We have sales quantity, we have price, we have variable cost 1, variable cost 2. Now let us try to see how we can use scenario manager to analyze this data. So we open the scenario manager under what if analysis, create the first scenario by clicking this particular feature add, and give it the name, let us say scenario 1, and it asks me which cells would you change to create the scenario. I say I want to change all the 4 variables over here. I could select like sales quantity, variable cost only. So I have that flexibility to choose the variables in the model and then say okay. Now it asks me what are the values that you want to put, which you can put over here, which is pop-up which comes here. So you see this B1, B2, B3, B4. So what are the different values you would like to put over there? So let us put some values. Let us say sales quantity 800 and profit, let us say 9. Let us say variable cost is at 4 and another variable cost at 3, and I say okay. Now I have generated one scenario. Similarly, I can create second scenario, again changing all these cells or say few cells. Let us say this time I want to change only 3 cells. So I can select only 3 cells and say okay. Now it accordingly the pop-up gets configured because of the selection. Now you have just 3 boxes over here. You can put, let us say 1100 here. Let us keep the prices like that, price and cost, and add another scenario. So let us say now we create scenario 3, whatever, and then again let us say this time we want to change these 3 cells, and we click OK. Now it asks me what are the values that I got to put in for these 3 things. So I will put, let us say 15, let us say I put 12, and I keep 3 as it is. Okay, just hypothetical, and I say okay. Now once I have put the scenarios, it could be as many scenarios I want, but only limitation with the scenario manager is that you cannot use more than 32 variables, and that is the limitation with this particular application. Now finally I want the summary. I want to understand what is the corresponding cost profit for these values. So it asks me what is the result cell. So result cell is the target cell which I want to analyze. So result cell here is profit, and I say okay. Now here it has created the scenarios. Now you see these are the current values in the first column. Let me just slightly expand it a bit so you can see this. So we have, these are the basic cells which we have changed. These are the first values that were there in the model. These are the values that we changed according to the scenario. So you could really build a lot of scenarios across and change the values and get the corresponding profit for that. But trust me, in any kind of data analysis, whatever you do, this whole thing is not really meant for you only. It is also meant for people who got to really see your presentation, see your output, and then discuss that. So it is quite important that whatever you do, it is understandable to others. So for that particular thing, you got to really name the cells so that they can understand what these cells were actually all about. So what we got to do, we will again go back to sheet 3 here and name these cells. So here I will name this cell over here. I will say this is sales, sales, and this one is price. So I am actually naming the cells now. So here similarly this is, sorry, I just did a mistake. So here this is variable cost 1, and similarly this is variable cost 2, and finally this one is profit. Okay. Now if I again go to scenario manager and generate these scenarios and say summary, now go to the cell and ask. Now this time if you see, and you will appreciate that we have been able to create a better presentable scenario output which can be understood by the people who are looking at your reports. So you have seen across all these three say tools which are used for the sensitivity analysis that we have to actually we can analyze discrete data, and we are in the first case limited to one variable, in the second case limited to two variables, in the third case we are limited to 32 variables. But trust me, it is really you have to put in effort to punch values. Now imagine a situation you are analyzing a complete supply chain of an organization in an international business, let us say, which have hundreds and thousands of variables working, and you want to really create very realistic model, and then you want to create different scenarios. Now putting all those values could be an humongous task. So it is always like for any kind of technology usage, it is important that there are two things which are essential. There is a benefit understood by the user, that the tool we are using or the support system we are using or the software we are using is beneficial, it has a utility. But another important thing that is quite important for the usage of the particular product is that it is easy to use. It doesn't take much of an effort to really use that. It is easily understood and can be used. So when we have such kind of an application where we have to put in a lot of effort to really make that thing work, there is some kind of a barrier. Now, and another thing that you must have really seen now, that we are putting no static values over there, but in real world the values can change in any direction depending on the behavior of that particular variable. Let us say cost has a behavior, price has a behavior, demand has a behavior. All things that we are basically looking at in analysis, data analysis, which we call as the variables, have a kind of a behavior. And the most very common kind of a behavior, what we call as a normal behavior, is depicted through a kind of distribution statistics, what is called a normal distribution. But there are other behaviors also. That means there is nothing perfectly normal. There could be some stretches on left and right, which is called skewness. And sometimes there could be spurts, which we call the kurtosis. So all these things really define the behavior of a particular variable, and that is the reality. That means if somehow we have some way to capture that reality of the variables, how actually price will vary. Let us say the price varies between 6 and 9, but there could be possibility of that it could be more towards the center, that it on an average it will remain around 10, but sometimes it may go down to 7, sometimes it may even go to 12, but more or less it will hover around say 9 to 10 or something around that. How do we really capture that? How do we really then calculate profit based on that? And then doing same thing with a lot of variables which are there in the equation, in the model. And there is this interesting application, what we call as simulation, which is very, very helpful in modeling. So how do we do simulation? How does one really use Excel to really do that, to really understand the whole process? Let us do one smaller exercise, and then we will take a smaller case to understand that better, and when time permits we will move on to the data mining. So let us have a look at another worksheet, and what I will do is I will show you how to do simulation and in a particular model. So let us create some variables. Let us say this is variable 1, and similarly let us say we have let us say 8 variables, we have this thing, and we create 8 variables. Let us say there are 8 variables which are there. Now to create the variability of the variables on the spreadsheet, it is important that we have some function, some tool which can help us to really develop that. So for that, there is an interesting tool which is called a random function, which helps us to depict uncertainty. Now if I put a random function right like this and press it, it generates a particular number. It is a random number, and if I put a delete key or a press F9 key, the number keeps changing. Now how do we really utilize this particular random function for our purpose? That means we want to incorporate the behavior of the variable, which is basically based on some historical say data, or it could be judgmental also. So how do we really do that? Let us see how we can really do that. Now if you look at the random function, the characteristic of this random function is that it generates values between 0 and 1 uniformly. That means all values are possible with equal possibility. That means if we draw a histogram of the normal of the random function, it will generate a uniform distribution. Now how do we really use this in our situation? Let us say first variable, let us say it was, for example, price, and let us say price varies between, let us say 7 and 20, and with equal possibility. That means it can be 7, it can be 8, it can be 8.5, it can be quarter to 9, it can be anything between, let us say, 7 to 20. So how do we really do that? So for that case, what we do is we will take is equal to the lowest value is 7, then is equal to 7, and then 13 is the portion which is actually varying. That 7 is the lowest threshold. After that, any value between 7 and 20. So what we do is 7 plus 13 multiplied by random function. So what happens is that I just missed an D over here. So here it is. That means now the moment I press I will just delete this thing. I press a delete key, we can generate any number between 7 and 20. It will be always within that particular range. Now let us say we don't want a fraction over here, then we can round it off. Say we just say round and then give 0 digits, okay, or say I say 2 digits. We are happy with that. So we have just like this. So we have been able to use random function to generate the behavior of a price based on our judgment, based on the historical data. We can do that. Now imagine, let us say our sales quantity. Sales quantity is not uniformly distributed, it is normally distributed. That means on an average the sales quantity remain around 1000, but it deviates, what we mean call as standard deviation. It deviates 100 left and right. That means 68 or 70% of the time the demand, let us say I will just write it for the consumption. So average and standard deviation. So let us say the average sales are 1000 and standard deviation is 100. What does it mean in fact? It means that 68% or 70% times your demand fluctuates between 900 and 1100. And there is a possibility also that it may come down to 800, but there is a lesser possibility because 70% is average plus standard deviation, one left, one right. So let me just see if I can just put some kind of a shape, sorry. So we have, let us say, yeah. So if we have like this, so you have this central portion, which is actually the normal distribution curve, and you can have an average over here which is 1000 and then standard deviation. Up to this point we have 900 to 1100, this portion which is the standard deviation, single second standard deviation. Beyond this is second standard deviation, right and left, which covers around 95% of the possibility. So out of 95, if we deduct 68, so we are left with around 22%. That 22% on each side means 11%. That means what is the possibility of say demand between 800 and 900 is roughly around 11%. That is how we got to really understand this thing. Now let us say the sales quantity on an average is 1000 and standard deviation 100. What is the function that we can use to really depict this behavior exactly as it is given? So there is a function which is called a norm inverse. So if we use this norm inverse function, it has 3 parameters which we call as probability, average and standard deviation. So we write in the probability rand function, and in the average we put 1000, in the standard deviation we put 100, and therefore we are able to get this sales quantity. But let us say the sales quantity is not in decimals, it is only in units. So we can just round it like this and say normal distribution, norm inverse, rand, 1000, 100 and then 0 decimal, and here we are. So we have been able to create sales quantity figure which is based on the distribution behavior, that it is normal, it is an average of 1000 and a standard deviation of 100. So if we press a delete key, now both variables are changing. Let us say the variable costs, let us start from now, this is variable cost 1. So variable cost 1, and similarly let us say we have 6 variable cost over here. Let us say all variable costs, let us say vary between 1 rupee and 2 rupee, okay, and with that are 1 rupee and 3 rupees, and they are uniformly distributed. So just to explain the concept, so let us say 1 rupee and 3 rupees. So 1 is basic figure, let us say we have created larger numbers, let us say 100 and 100 as the base figure, and then rand function multiplied by, let us say, another 100. So we will have values between 100 and 200. So all variable costs, 6 variable costs are between these particular figures. Let us, for the price, let us just increase it a bit. Let us say I keep price at 1000 and just keep it 200. Okay. Now I have created price with, say, between 1000 and 1200, and variable costs between 100 and 200, but I have created 6 variable costs over here. So if you see, I just dragged it, I have been able to create behaviors of 6 variables. Now thing is, what would be the profit? So I write the profit equation like this, and I go here, I just write now sales quantity multiplied by price minus, okay, sum of all these figures and close it. Here is my profit. Now this profit, if you see, if I press a delete key, this is based on all the factors that I have given, all the variables which are given above. But the important thing is, the moment I press a key, I develop a new scenario and a new profit. Now what is really important for a decision maker, you got to really know what would be the behavior of the profit given the variability of all these variables which are there, price, sales quantity and variables. It could be thousands of variables. Same method applies. The thing is, how do we really capture the behavior of the profit? Now what we do, we use the tool, as I said, called simulation. So what we do is, we simply refer this profit over here like we did in the one-way, two-way table. We take a blank cell on the left and select as many as number of cells. We can select thousands, more the better, and generate values over here. Now say what we do is, we go back here. So we have taken a left cell on this, we click this data, we go to the data analysis and take data table and go to the column input, press a blank cell over here and say OK, and here is our data. So we have been able to create profit based on different scenarios of variable cost, sales quantity and price. But the important thing is that what do we do with this data? How does it really help us to really get more insight? So for the time being, I will just freeze this data, copy paste special values, okay, because it is based on random. So moment we press a key, everything will change. So what I do is, there are some interesting numbers to really look at. One is the minimum value of this whole range, another is maximum value of this range, another is average of this whole thing, and the last one is, for the time being, is standard deviation of this whole thing, which will help us to understand more about this data, because these are the parameters. So how do we derive the minimum value of this whole thing? So we go here, we take is equal to minimum, select this entire thing and press return key. You will find that this is the minimum value. Now what I will do, I will freeze this value so that I can copy it, okay, and then I can calculate other values. So this was minimum. Now let me just change this to maximum. Sorry. Okay, maximum. Just a minute. It is like this, and then this one is average. Here it is average, and then okay, and this one is standard deviation. Okay, so here it is. Now we have calculated, we have created these values over here. Now what do we do with this? Now let us say we were trying to figure out what is the risk factor in this whole, say, data. What is the risk factor in the profit? What is the possibility of making a profit, and what is the corresponding risk for that? One is that we could really calculate the coefficient of variation by dividing standard deviation by average and calculate coefficient of variation multiplied by 100. That is, we can also do that, but more important is that we should be able to see the profile of this whole data. And what we can do is, let us say we want to create a histogram. Is the best way to understand a single variable profile. and cluster scatter diagram for the association. So let us say we want to create let us say some 15 intervals for the value, and then want to create a histogram. So what we do is equal to minimum plus maximum minus minimum, minus minimum, and divided by 15, and whole thing is multiplied by this particular thing, and then we freeze this thing over here, and we freeze this particular cell and say okay. Now you will notice this will equal the minimum value, and similarly if we just pull it down up to this point, we will get the interval thing. Okay, let me just see what has happened. This thing, so okay, so this one is equal to D16, and this one is equal to D17. Okay, so E12 minus E12, so we have done something not really correct. So let me just rework E11 plus E12 minus E11. Here it is. Okay, now it is correct. So we have been able to create the intervals as we have here, based on, now we have sliced the entire data into 15 parts. Now we want to find the frequency of the data that we have calculated for the profit. So what we do is we select this entire column and use a kind of a function in Excel, which is very, very powerful function, is frequency function, which is actually a what we call as the array formula. So we say frequency, and then in the brackets what we do is in the first parameter we put the data range, which is over here. So we take this entire data over here, then comma, and then go back and take the interval data. So we go here and we take this interval data, close the bracket, then we press 3 keys simultaneously, Control, Shift and Enter. The moment we do that, we should be able to get the frequency. So here is the frequency. Now you can portray this frequency using the bar chart and understand what the data actually looks like. So if we just slightly contract it, and then you can see, and only thing is we got to refine the x-axis by going to the, I will just take it slightly this way so that you can see it. So here it is. So what we do is we will now refine the x-axis by going to the select data, click on the edit and take these values over here and say okay. Now this gives us the complete profile of the profit figures based on the movement of 8 variables, that is 6 variable costs, price and sales quantity. Okay. Now this is something that is interesting to really know when we have huge amounts of data using Excel by using Monte Carlo simulation. Now another thing that you would be interested to know, what is the possibility of making a loss? Okay. Now how do we really do that? Here you will have another very interesting function, so which will help us to really do that. So what is the possibility of making a loss? Possibility of loss. So what we do is we write a formula which is called norm distribution and say what is the possibility, what is the cumulative probability up to 0 with the average which is over here, with the standard deviation which is given over there, and cumulative we put 1, okay, a true condition. And this is what it is. That means the possibility of making a loss is 2%, or precisely if you want to really put it, so you can say 1.773. So this is the kind of analysis that can be done using Monte Carlo simulation and can be done with the help of existing tools. You don't have to actually learn a particular code, is only just remember certain functions and their utility, and can pull these functions together and to make more sense out of it. So let us take one simple case to really and so we have another 25 minutes. So what we will do is, now let us close it over here, Excel, I will show you another application which will make you appreciate the application of data mining in a very simple retail case, so that once you are interested, you can develop yourself further on that particular application. So let me just close this thing over here and open another application which we call as Clementine, which is now called IBM Modeler also. So if you look at this particular tool, it has a canvas in front of you and there are a lot of icons down below over there. So these icons help us to get the data, refine the data, transform the data, and finally apply models on top of that. So what I will do is I will show you a simple application of how a retailer who has, say, customers coming and asking for different products, how that guy can really understand what are the products which are bundled together, which customers prefer to buy together. That could be very interesting for various reasons. That guy could throw a sales promotion based on the bundling of the products. That guy could actually make the whole display plan according to that kind of an information. That person could actually, develop the whole signage, I mean the price tags, arrows, everything, and the information for the customer. Because if I know a customer who buys product A also is likely to buy product B, and if you buy both A and B, then possibly you may buy product Z also. So if I know this combination, I may really control a lot and influence the behavior of the customers in the retail outlet itself. So how do we really do and use this application, which is actually a data mining application, to do this thing? So there is a kind of file down below which helps us to, which is called a variable file, to pull that data. So I will just squeeze it a bit like this. I think now you can see it. Okay. Now we have this variable file which I got. I will just delete it so that you can see where I have got it. So there are different, tabs over here. The first tab is the favorites, which is very common from the Microsoft days. You understand what are the favorites. But second tab is the tab which will help you to get the different types of data, whether data is in any corporate database, whether it is an Excel file, SPSS file, whatever kind of file. There are different formats. You can pull any kind of file and wherever it is. Now for the time being, in my case, it is on the folder on the desktop itself. So I drag this file, this icon over here, open it, and just click this browser over here and open a file which is called baskets and say OK. Now what we have done is we have got the data which is basically about a retail shop of around 1,000 customers, and let us have a look at this data. So there is these different tabs. I said there is another one tab which is called output, where there is a particular icon which is called a table. This table is very useful to see what kind of data is lying inside at any point of time. So I just execute it. You can actually see all the data is now appearing over here in a moment. Okay. Now if you look at this data, there are these classification profiles, the profile of the customers, who are the customers, what is their income, how much they have spent. So this is a monthly data about customers, but on this side you see these are actually products. These are different products that customers brought from the retail outlet, and this whole data is just dichotomous, true or false, whether they have brought or not. Now how can we use this information, if such kind of data? And quite possible nowadays most of the retailers capture this data through scanners and through RFID or whatever. So there is a lot of data capturing and data sourcing possibilities in the retail and in any kind of business, so which we can really leverage with these kind of tools. Now let us see how we really do with this thing. So just we close this thing and then go to, there's another tab which is called field operations, which is meant to actually activate the data and put it through the whole model and refine variables based on our requirements. So what I do is I just open it, I just do some things. So there is actually I am trying to define the variables according to our requirements. So if I just give you idea about the variables which are here: value, payment method, sex, homeowner, income, age, and then our items, and different items like fruit, vegetable, fresh meat, dairy, canned vegetable, canned meat, beer, wine, etc., etc. So there are different products. Now what I do is I have to define the type. That means what type of variable it is, like ordinal data, scale data, ratio data, so which we discussed yesterday to some extent. So I will just do some simpler settings over here. and then I need to define the direction, because in any kind of analysis it is quite important to understand that there are two things. One is that we don't have a set dependent variable, which is basically the variable under investigation, or we have already identified it. But in this kind of an analysis where we want to find out how items are associated in a particular retail outlet, which items go together, each item in the process becomes an independent variable as well as a dependent variable. So we have to define the direction of the variable, which is in this case both. So what we will do is, from the first cell up to the last cell, we will, just a minute, we will say, we will define the variables, and none. So here we have both. From here onwards we keep everything as both. Both means it is both the independent variable as well as dependent variable, and then so we have defined each variable in terms of its direction, whether it is independent variable or dependent variable, and whether what kind of what type of variable it is, which is almost done by the system by default, which we have to adjust in case there is a need. So what we do next is we just say OK. And now, as I said yesterday, while we are approaching the analysis, we first start with exploratory data analysis, that is getting the descriptives, and possibly the graphs is the best way to explore the data to understand any possible, say, linkages or associations. So we click this graph tab over here. There's a very interesting graph tool over here in the this particular product, which is called a web tool. So we just take this web over here, connect this particular field or type to this particular graphic tool, we link it over here, we say select all and remove couple of these and say OK, and select all and OK. Now we remove couple of this, and then we say show true flags only, and then execute it. Now the moment we execute it, you will see something interesting appearing over here, now which is basically all the associations between these items are now shown over here. That means what all items actually go together. Now it looks quite jumbled over here, you may not be able to actually figure out what it actually means, but we have a very facility here which is called a slider. The moment we move the slider on here, we are able to pinpoint those important combinations in the items. You possibly may not be able to see, but just let me read it out for you. One combination is people buy fruit and vegetable and fish together. Second combination here is people buy wine and confectionery together. And the third very interesting combination, which is the most powerful combination out of three combinations, is people buy frozen meal, canned vegetable and beer together. This is something very interesting. Now thing is, what is the size of this particular market, and how confident we can be if we really procure material and put displays according to this kind of a combination. And for that we need to actually use something more robust and more advanced. So let us just close it over here and then take another tab over here which is called modeling, and in the modeling down below there, because this is an earlier trial version which we are using right now, we have maybe around some 12 or 13 models, different types of models here, but in the current version I think there are more than around 25 or so models. That means different type of tools, techniques are available to analyze data based on different situations. So for this kind of a data which we want to analyze and establish the associations between these products and then strategize and do tactical marketing based on that, we can use a particular feature which is called a particular methodology which is called market basket analysis or variable association, which helps us to understand the association in terms of the precedence and the antecedents and the successors of say purchase process or the sequence. So let us take one of the models which is available over here, which is called a GRI. So let us just connect this to this and just simply execute it. You don't have to write any code, you have to only do it once or twice. I think in just 2 or 3 runs you will be almost running it almost like a professional. But only thing is, the more important thing is to understand the interpretation part of it. Whatever data comes, whatever outputs come, what do they mean and how do you really use that? And that is how the whole business support application is moving. They are trying to make it much more easier for the users, making it much more simpler for the users to understand this. So if you look at this data now over here, you will find very interesting things, that people who buy fresh meat, frozen meal and beer, the heading is antecedent, also buy canned vegetable. That means it's a consequent. That means if you buy these 3 items, you will buy these 3 items. And what is the support? This support percentage. That means 3%. Confidence percentage 96%. Now let us try to understand what are this support percentage and confidence percentage. Support means that what is the size of the market. Let us say this is the record of 1000 people. Out of 1000 people, 3% actually go for the antecedents. If 3% go for antecedents, out of that 3%, 96% will go for the consequent. So out of 1000, 3% would mean 30 people. So if you have 1 million customers coming every week or every month or whatever it is, so you can actually anticipate or expect that many number of customers possibly going for this kind of a combination, and the kind of confidence you can have is that 96 is a great confidence. So both are important, but to begin with, unless there is a big market over here in the support percentage, you may have high confidence that really not make much sense unless you have a support percentage. But it also depends on the kind of product we are talking about. Let us say it's a high environment product, a high value product, possibly a smaller support may even be quite interesting to you. So this kind of an output you can really restrict based on the kind of options that you get, because this is too lengthy output. You may not be interested to really see all. You may be interested to pinpoint the whole analysis on most important combinations which have higher support and which have higher confidence. So these are the kind of features that are given in the model options. So minimum antecedent support percentage, it is 0 over here. Let me raise it. I say my support should be at least, let us say 5%, and my confidence should be more than, let us say 70%, and let us say I keep maximum number of antecedents limited to 2. Can I get any combination? If there is, I would get it. So if we open it, now we have only 3 combinations, but trust me, these are the 3 combinations, same combinations that you actually saw while we were doing the outputs. So this combination that you saw is beer, canned vegetable and frozen meal is the combination that is appearing here as the most powerful combination. Frozen meal, canned vegetable and beer. So support percentage is 16.7%. That means 16% of the people. So for 1000, that means 167 people are actually going for the antecedent canned vegetable and beer, and possibly they are likely to buy frozen meal after that. And what is the confidence for that? Is 87%. This helps us not only the display, not only the marketing promotion, this also helps in procurement and inventory management of these kind of what we call as the bundled products. So after having done this, next question for the marketer could be, who are the people who actually buy this kind of a combination? Because unless you are able to target the people, what is their profile, so that you can do very targeted promotion, you can select the right media for them and then throw marketing campaign accordingly. For that, there is another very interesting tool to look at, which are called classifiers. So classification and regression tools is very, very helpful to understand the profile of the customers who go for this kind of a combination. But before we actually go for this kind of a combination, so we will have to do something more. That means we just open this thing, and okay, let me just open the output. We will take one of the combinations. Let us say we take this combination over here. Let us say this combination. So we have to click on this, it becomes red, and then generate derive node. So the moment we generate a derive node, what we are actually doing, we are creating a new variable over here, which is based on this particular combination. If you open this particular derive node, you will find that possibly people canned vegetable, beer, and third one has not appeared. So we need to really do a fresh this thing. So just a minute. So we just open it over here. So this one, generate derive node, and say here, yes, so we got it here. So let me just put it over here. This one is the right one. So this is the combination we are interested in. We may give it a name so that we can analyze it in much more sensible way. So we say trio combination, let us say trio combination, and say okay. Now we just join this thing with this thing, and if we want to really look at the data now, how does it really look like after we really add this thing and execute the output tab, you will find that there is a new variable which is appearing at the end, which is trio combination in the last. So this actually flags true for all those particular records, all those cases where people have brought all these three items together. So that is the new variable we have put in. Now what we are interested in is who are the people who are buying this trio combination. So we again have to redefine now the variables. We connect it to the type again and redefine it. So in this case now all profile variables will become the input independent variables. Like any regression case, we have same particular procedure has to follow, and then all these items become none, and only the variable which we have taken for the analysis will become the dependent variable, will become the out, which is trio combination, and then we can see the profile of the customers. So here we are, and confectionery none, and this is the last strike one. This will keep us the out. So here the target is defined, so we don't keep it both. So target becomes the dependent variable, profile variables become the input variables, and we say okay. Now we have to get a model over here and do, let us say, quest model here, join this type to this one and simply execute it. You will realize that in a minute we will have this particular model developed, which will tell us exactly who are the people who are actually buying it. So if we open this, you see a complete rule list. That means income less than this much, sex male are actually people who buy this combination. But if the sex is female, it is a false condition, that is they don't really buy it. So you have all the rules that will help you to define who are the customers who buy this particular product. Now you may like to have everything in a much more sensible and a presentable way, which you could really provide to the marketing manager so that they can work on that better. So you can generate a rule set which is much more elaborate and meaningful. So if you click this thing, you see there are all the rules which are appearing here, false rules and true rules. So starting with false rules, these are the false rules, that if income is less than this, sex is female, they don't buy. If income is more than this or less than this and it is a male, still they possibly may not buy it. So you have got all the conditions that of the customer profile who are likely to buy the product. But thing is, how accurate is this model? If we actually generalize this, like yesterday I was talking about descriptive analytics and then finally validating it for the entire population. So how good is this particular model for the entire population? That is validation. So what we can do is we can possibly test it through a particular tool which is available here in the tab, which is called analysis. So we join this particular icon with the analysis, open it up and simply execute it. The moment we execute it, we get a complete validation picture. That is how many are the correct predictions and how many can possibly go wrong. It says 96% times 96% predictions are correct, but at the same time 3.4 can go wrong. This may be a good situation for a retailer, but it could be a very dangerous output for a pharmaceutical product. That means you may not be able to treat a very critical disease with a very critical product, and that is why what we call as these lift tables or confusion indexes, they actually help us to figure out how much right you can really judge and how much wrong both you can judge, because both become very important in the final analysis. So now you just saw how we can really use one of the applications of say data miner, and how beautifully it is able to do everything. And I didn't take more than say 20 minutes to analyze huge data. It was just 1,000 records. It could have been million records or much more than that. Simply you need to really understand few say basic steps in the tool, and make more sense out of it, and can really help the decision makers in the organization do a better job. So I think we have shown you how Excel can be used, which is basic application which is available everywhere. But these kind of application like data miners or simulators, they come at a cost, not available everywhere. But you can always try it, and if you are convinced that your organization or your department really needs this kind of a tool, then you can actually pursue them or convince them. But you need to be sure about that there's a utility for the organization, because many a times we go for a lot of analytical tools, but organization doesn't really need it. Our organization doesn't need that kind of say highly advanced tool. So you have to also see the robustness of a tool, the complexity of that particular tool, because the more complexity it can handle, more costly it will be. So you have to also do that kind of a selection and judgment while you are choosing a tool for your particular organization. But last but not the least, so over a period of time, I think this has become, the analytics has become the grammar, as I was telling you yesterday also. So it is always good in terms of say career growth, in terms of a good sound decision maker to understand and learn these particular tools and apply in your situation. Also at the same time, for people in the academic sector, it is quite important to really look at these tools and approach problems from different perspectives, different say analytical tool, what we call taking the approach of different analytical tools, because one study could have been done with say earlier tool which didn't have that much of robustness. One could always look at more modern tools and look at the same thing and revalidate certain things which have been really confirmed in the past. So thank you very much, and I hope you have been able to understand and learn a bit whatever I have been able to contribute. Thank you.
Okay, can you suggest if someone wants to learn on their own, so what is the best way to learning this? Are the books available for this in the market?
Yeah, sure. There are a lot of books which are now available in the market. Earlier, yes, there were not really much books available in the market. I can say there is also this what called Decision Sciences, Management Science by Albright and Winston, and there are a lot of other books also written now by Indian authors which are on this particular subject, where they have started including these decision support applications. So even from the Microsoft itself, there are a lot of publications about how do we use Excel for modeling, which is very interesting and very written in a very simplistic way. So this is one thing. Other thing I can really suggest, there's a lot of information about all these tools available on YouTube, on say internet. So I think that's the best resource you can really look at. And plus these organizations, most of these organizations who have these kind of tools, they have their websites, they provide a lot of say user manuals, and you can always use this product as a trial. So most of these products are say available on say let us say 15 days or 1 month's trial. Another thing for academicians and students, there are always some price concessions, and you could always avail that kind of a facility. But definitely there is a lot of material and lot of exercises you can always find for good softwares, I would say, which are very common and popular. You can always find on the internet.
Okay, so as per the requirement of social science scholars, the software which is different from the managerial point of view,
yes. So I would always suggest that for people in the academic sector, it depends on what kind of projects they are pursuing. Let us say somebody is doing say some study in economics or econometrics, they possibly may go for a product called eViews, which has a lot of compatibility, a lot of which factors, lot of concerns of the econometricians. But if you are doing something in psychology or sociology or management, even some basic and even advanced things can be done with now the SPSS IBM product, or say SAS. SAS is of course very user friendly and very accurate and supposed to be quite popular in the Western world. And similarly you have Minitab, R, you can use a lot of the products, but I think in India SPSS and SAS have become very common.
So well friends, with this word we conclude the lecture today, and I thank all of you for watching the lecture, and on behalf I thank Dr. O.P. Varli for giving such a wonderful lecture, and tomorrow we will discuss SPSS. Thank you very much.
Thank you.